So I recently made a post on LinkedIn where I said learning data science is hard, really hard actually. To be very good at this stuff, you should know ... a list of many different items. In this video, I want to say each of those items one by one and then kind of talk about the sub areas of each of those and a little bit about how they connect between each other because they're definitely not like completely separate ideas. So go over each of those concepts and say what are the most important pieces of each of those. So firstly, linear algebra. Well, you definitely should know vectors and matrices and, the operations between them. So like matrix multiplication, dot products between vectors, that type of thing. If you want to learn that, I recently made a video on that, and you can probably find that in my top 5 most recent videos. The next one I wrote was calculus. So really the main point of calculus, and you should definitely understand what a function is from grade 11 or grade 12 mathematics. And then after that, you should learn about derivatives. So that's basically, taking a derivative of a function, you get another function. And the reason that that's important is mainly because it allows you to do optimization. And that was actually the third thing I wrote. Optimization, they are really, very, very closely intertwined. The main reason we need calculus and optimization for machine learning is because for machine learning, we're pretty much always just trying to minimize or maximize, usually minimize some function. And so you need to know what that means and what a function means, what it means to minimize a function, and sort of kind of how we try to minimize those functions. We usually use something called gradient descent, or in something slightly, more complicated than gradient descent, things that go very slowly one by one and try to minimize a function. And so that's what a neural network does. It's not what everything does. A random forest will not really use gradient descent most likely. It'll do some other means to minimize a different function. Okay, so pretty much all of it is about trying to minimize a function. So you should know linear algebra, calculus, and optimization so you understand, functions in general, multiple different dimensions, and how we might go about doing that. I then wrote statistics, which is probably somewhat self-explanatory. It pretty much is a statistics field. Data science, it's very synonymous with statistics, but the most important parts of statistics are regression, statistical learning, which is basically a synonym to machine learning. So later down the list, I wrote machine learning as well. Statistical learning or statistics, it's very, very closely intertwined. They sort of kind of mean the same thing. You need to know what random variables are. You need to know, I wrote probability. Knowing different probability distributions is not a bad idea. I don't think you need to know all of them. There's so many of them, like Poisson and all of that stuff. Pretty much make sure that you know what a Gaussian distribution is and how histograms kind of model that graphically. All of the different plots as well, like scatter plots and pie charts, is very useful, both to know that from mathematically what they're doing, why you might want to do those, and how to do it in a computer. It's very easy to do it in a computer, Matplotlib or Seaborn or Plotly. Do it, in one line pretty much. You just import it and you do it. So in statistics, yeah, random variables, distributions, and honestly, maybe a little bit about sampling distributions, not too much. But after that, just make sure that you learn the statistical learning part, which implies machine learning. It's like the bias variance trade-off, what underfitting versus overfitting it is. Really, it's the same as bias variance trade-off. And that means you're probably good to go. And you can go as far as you want into the machine learning or statistical learning, they're synonyms, depth as you want. You don't necessarily need to know, all about how a naive Bayes algorithm works or how random forests are built, but it's probably a good idea if you can. I then wrote programming, which is a massive field on its own. I'm actually in the process right now of making a full one singular Python video where I just, assume absolutely no background and go as far into depth as I think is, necessary, or at least necessary until you really have to go off on your own and just kind of learn things as you go. Everybody does that. That's just what you have to do at some point. And so programming, yeah, all of that stuff, object-oriented programming, design principles, all of the complicated programming stuff that you think might be only relevant to programmers. Maybe that's sort of kind of true, but especially in big tech companies, they'd want you to know all of the algorithms and data structures stuff for your own well-being. Knowing all of that stuff will make you a better programmer. Data scientists are programmers by heart. You will be doing mostly coding, if you're good at it, and that's the right way to go. So learn programming, whatever programming language you want. Please make it Python. I'm wearing the Python hat. But sure, any language you want. Am I sounding contradicting? Yeah, probably. I very highly recommend that you learn Python, but you can learn R, you can learn Julia, you can learn Java. Learning multiple languages, not a bad idea. But I very strongly think that Python is the way to go right now. Maybe in 5 years from now, I'll be saying, why did I do that? Why didn't I suggest everyone move to Julia? Right now, please learn Python. It's in your best interest. I then wrote SQL, which is basically, programming as well. It's still a programming language, but it's a very particular programming language that has a set of rules to manipulate relational databases. So I did actually write relational databases as well. They're really the same idea. It's learning how relational databases work, how we store data, how you can extract data from those. And once you got that down pat, move on, and you may or may not use actual SQL all the time, but the principles that you learn there, you will use all over the place. I then wrote visualization. I feel like that's relatively covered already in the statistics piece, but maybe more into like dashboards or some front-end development. Not a terrible idea. Big data, so that pretty much implies Spark, Hadoop and all of that stuff. I think Spark by far is the most important one. Learning the MapReduce algorithm, how we kind of parallelize data, and even just vectorization in NumPy, for example. All that stuff, you don't necessarily actually do that, write that MapReduce code. You use something like Spark that abstracts it, but big companies will definitely want you to understand this stuff and be able to code it in, say, PySpark. So I highly recommend you get on that. I then wrote cloud, so GCP, Azure, AWS, Heroku. You probably know the names. Make sure that you can use at least one of them, deploy some apps, do something interesting, put it online for people to see, and that's really all that you need to know. You can go as far in depth into the web development aspect as you want. It's always valuable, but I think at a point it stops being completely necessary for sure. I then wrote machine learning. That really is covered in the statistical learning part of statistics, but I guess it also implies, I'm not sure if I wrote deep learning. Yeah, I did write deep learning too after, so neural networks, how to train neural networks, the bias variance trade-off around all of those, you will need that. I then wrote MLOps. MLOps stands for machine learning operations. It's really just a fancy word for saying, be able to deploy applications, understand the workflow, which you don't really get until you go into companies, but you can take Andrew Ng's or at least deeplearning.ai's course on machine learning ops, and they'll give you a hint as to how they do that in companies. Computer vision and NLP, both of those are kind of different topics, but I think it's a good idea to at least get a bit of a flavor of both of those so that you understand the neural network architectures are pretty overlapping, but how they're a little bit different sometimes. And I think they're both really cool, so I recommend that you do explore them. And by no means there's no way of combining the two. You can easily have a model that takes text and visual data, and maybe you might do that someday. So learn both. Also, I didn't explicitly write object detection, but I kind of implied that under computer vision. Definitely read those papers like YOLO and the other one, RCNN, if you can. Now again, I wrote you might not need to check every single one of these boxes, but I certainly would attempt to check as many of them as you can. This isn't meant to be daunting, but instead a reality check that this won't be a walk in the park. It's true. I'm really not trying to scare you, but I am trying to set some expectations and just let you know there's a lot of pieces to learn here, and it just takes time. You just have to sit down one by one. If you ever find that you don't understand something and that there might be some prerequisites, so you need to learn earlier things, take your time, do that. Don't learn things that are kind of impossible for you to learn. Learn what you're interested in, so don't just do things because someone like me or someone else told you to learn something. Learn the things that you're interested in, and you should be able to get it. Just give it time, and I promise you'll get there eventually if you try hard enough.